Okay, in this lesson we're going to continue on looking at and working with the slope-intercept form of a line. And if you remember, slope-intercept form of a line is y equals mx plus b. Really what we've done in the last lesson is we really focused in on that whole idea of slope, which is the m part of that formula. We went ahead and looked at two different points here, or two different lines identified by two different point sets. This first one was the starred one. We looked at the 0.48 compared to the 0.25. We looked at the difference in the x-coordinates, the difference of the y-coordinates, and set up this ratio, because that's what slope is, the change in y over the change in x. And so we found in that first one we had a slope of 3/2. In other words, to get from one point to the other, you counted up 3 and to the right 2. When we calculated the second 2 points that were identified by the dots, we came up with a slope of -3/5. In other words, to get from one point to the other, you counted down 3 and to the right 5. That negative slope, you can see, decreases. It falls going left to right, whereas the positive slope increased going left to right. So we did a little more practice with a few other points here, or sets of points. Calculating slope. I did this one in the method of connecting your x's, connecting your y's, and setting up the ratio and solving. Whereas this one, I stacked the two numbers, and I asked ourselves, how did we get from this x-coordinate to this x-coordinate? We identified that we added 5. How did we get from this y-coordinate to this y-coordinate? We identified that we subtracted 4. Because this is the change in y that goes in the numerator, this is the change in x that goes in the denominator, so we had a slope of -4/5. And we plotted each of these. We could see this first set when we had a slope of 2/5. We could see again this increased going left to right. This had a positive slope. In statistics, a lot of times we call this a positive correlation, that there's a relationship between the x and the y coordinates. As x increases, y also increases. Whereas over here, we had a negative slope. It fell going left to right, and that's called a decreasing relationship, or a negative slope, negative correlation. In other words, as x increases, going from -2 to +3, y decreased. So there's that decreasing relationship between the x and y coordinates. So that's a fast and furious review of our last lesson. The next thing in your notes is these two problems here on the next page. I want to fly through that as quickly as I possibly can so we can get to the meat of this lesson. So I've already worked it out, and I just want to discuss what we did here. Same thing that we had going on. We have 2 points here. I stacked them to find my change in x and then my change in y on the right. And when I set this up, my change in y is 0, so I have 0 in the numerator. 0 over any number is going to be 0. So this is a 0 slope, and we've not had that before, so I wanted to show you what happens there graphically. So when I plotted these points, -2, -4, in other words, counting from the origin, -2 down -4, and then plotting the -5, -4, back to the origin, counting back -5, down -4, I could see these two lines, or these 2 points, fall on this horizontal line. So what I want you to see here is that when you have 0 slope like that, it comes out to be a horizontal line. And graphically, when you look at that, it's like, oh, okay, that makes sense now. We've got another unusual scenario here. I've got 6, -3, 6, 1. I stacked them again. How did I get from this x-coordinate of 6 to the x-coordinate of 6? 0. I didn't do anything. How did I get from a y-coordinate of -1 to 4? I added 4. So in this one, my change in y is 4, and my change in x is 0. And this is my slope. And we're like, how do we interpret that? Because if you go to your calculator and you plug in 4 minus 0, or 4 divided by 0, you'll get an error, or undefined. Basically, this is undefined. And you're like, what does that mean? So I'm going to go ahead, or I went ahead and plotted each of these points, starting from my origin, over 6, down 3, again, starting from my origin, over 6 and up 1. I've plotted each of these 2 points, and when I connect them, I can see that this has a vertical line. So we can see this doesn't even go through the y-axis. This would be an undefined slope, and it kind of makes sense because as you're plotting from going from one point to the next, there is no movement to the right or to the left. Whereas over here, there is no movement up or down. Okay, all of the things that we kind of talked through in the previous slide or the previous page as well as this page are kind of put in print form for you right here, and I'm not going to go through that. I'm going to try to get to this point down here because this is where I want to get to the meat of the lesson, and that is all in this statement right here. We are going to start graphing lines that are in this slope-intercept form. And again, slope-intercept form means it follows the format of y is equal to mx plus b. Up until now, we spent a lot of time talking about m, slope, how to calculate slope, and that it's created by the change in y over the change in x between any 2 points on the line. But now we want to start talking about the y-intercept. The y-intercept is this last point right here, this last term. That's where it crosses the y-axis. And so that point, that component of our equation anchors this line to the y-axis. And then once we, from that point, if we plot that point, from that point we can count out the slope. So we're going to be using both slope and y-intercept. And that probably doesn't make a whole lot of sense of what we're going to be doing until we actually start doing it. And then I'll also bring in the idea of how this all comes about in statistics and looking at a data set, looking for positive and negative correlation. So we're going to go to town on a couple problems here, a couple linear equations that we're going to graph. And we're going to, all of these are written in that slope-intercept form, which again is, the format is y equals mx plus b, where this last term is your y-intercept and this term right here is your slope. So we're going to be using those two components. But we're always going to start here with the y-intercept. So in this case, I have a y-intercept of -2. That anchors this equation down to the y-axis. That's where it crosses the y-axis at -2. So I'm going to go to that point on my graph. And I'm plotting -2 here on the y-axis. From that point, I'm going to count the slope. So I have my numerator in slope is 3, and again, that numerator is the change in y. So I have from this point, I have a positive change of 3. So I'm going to count up 3. 1, 2, 3. And then from that point, I'm going to count to the right 5. 1, 2, 3, 4, 5. Those are 2 points that are on my line. So I can take a straight edge and connect those 2 points and see what my line looks like. Okay, same thing with this problem here, except this one, it crosses the y-axis at 2. So again, from my origin, I'm going to count up 2. That's where it crosses the y-axis, at 2. And again, I'm going to count my slope, which is up 3 and over 5. 1, 2, 3, and over 5. 1, 2, 3, 4, 5. And then draw any kind of a straight edge to draw your line. Okay, I want you to see here that these each share the same slope, and they look really similar, except they just cross the y-axis at different places. This one crosses at 2, this one crosses at -2. I just wanted you to see that when you have the same slope, these actually create parallel lines. If I had them on the same set of axes, you'd probably see that. Something else I want to point out, when we start graphing these things, I want you to recognize that on the graphs that I have here in the notes, that the y-axis can be a little tricky to find your point, because the numbers for the y-axis on the positive are just a little bit above the line that they're depicting, whereas the numbers for the negative components on the y-axis are a little bit below the line that they are depicting. So just be careful when you're plotting your points there. Okay, our next one, we have a slope of -1. So I'm going to count to -1 on my y-axis, which is right here. And this time, the numerator is -3. So I go down 3 and to the right 5. Okay, I want you to look at both of these. It looks like our slope is, the same slope, except one's positive and one's negative. And I want you to see how that slope really changes the direction of how this line plays out. In this next one, we have up 3, and then from that point, we're going to count down 4 and to the right 3. And then draw a line, and this one just became a little bit steeper. but also falling. And it crosses at a different place. Okay, so just in a nutshell, you're going to identify, plot the y-intercept first. You're going to count up or down the numerator first, or second. So that's your second step. And then your third step is you're going to count this number to the right. Just to kind of keep you going through. So it kind of feels like you're going in that direction. Okay, so in each of those cases, you had a line, a linear equation in slope-intercept form, that y equals mx plus b. Okay, so now we're going to look at a couple problems or a couple equations that just look a little bit somewhat different. A few of them do. Okay, this first one here looks like we've got a slope, but it doesn't look like we have a y-intercept. But I can put this in y-intercept form by just saying plus 0, and that gives me my y-intercept. So I'm asked here to identify, find the slope and find the y-intercept. And so I might, if I'm asked to do that, I might say m is equal to 5. And I might write that in 5 over 1 because I want that in fraction format. And then my y-intercept, which is b, is equal to 0. And then I can go from there and plot it if I'm asked to do that. So this crosses at the origin, and we're going to count up 5 over 1, and we're going to see that, wow, this one's a really steep equation or line here. So the bigger the difference between the numerator and the denominator, you're going to see more drastic effect on the slope of the line. And this one here, there's really nothing new here. This crosses the y-axis at 6, so I'm going to count up to 6. So 1, 2, 3, 4, 5, 6. And then I'm going to count down 3. 1, 2, 3. Now again, it's from that point. You're counting your change in slope from the y-intercept because you have to count from the point that was on the line. Negative 3 and then over 2. And then connect them. Okay, so nothing really strange with either of those two, but these next two definitely, we've got some strangeness going on. We've got y is equal to 5. So it looks like we have a y-intercept, but we don't have a slope or anything. But let's go ahead and count out that y-intercept. So we have 1, 2, 3, 4, 5. It crosses the y-axis at 5. And basically, it's just saying that every point is going to have a y coordinate of 5. So this creates a horizontal line. So when it's in this form, we have a horizontal line. And here I have x is equal to 6. So that's just saying that every point has an x coordinate of 6. So it crosses the x-axis at 6. So when I plot that, I can see that I have a vertical line. So this one here is my vertical line. And if we go back to the problem that we looked at originally from the previous, that kind of makes sense. Both of these had an x-coordinate of 6. This went through, this created a vertical line that crosses the x-axis at 6. Whereas here, both of these had a y-coordinate of -4, so it crossed at -4. So that kind of makes sense that when they share the same y-coordinate, all points on that line are also going to share that same y-coordinate. And I'll end this lesson now. We'll pick up with more graphing on linear equations next.